Okay, well, I don't know what else to say other than I've had it. That's it. So, um, big thanks, and I don't know what else to say other than adios. So, been nice knowing you. You can see the benches, it's being torn apart. So, complete dismantling. I'm going down to Bearwood. Yeah, bye. So, what can I say other than put the destruction music back on? A little bit of napalm death is great for tearing crap apart. Let the destruction continue and have a nice life. Okay, so April Fools. Yeah, Mike ain't going nowhere. Mike just had some major bench remodeling to do because we've got a shiny new toy on the bench to play with. This is, I guess, you could pretty much consider this cutting edge technology of today. This is current production Roda and Schwartz CMA 180 radio test set. So yeah, this doesn't get much better than this, folks. I've been saving up for a long time to get a communications test set, and voila, here it is. So right now, I was sweeping an audio frequency through it, but this instrument does absolutely so much, and I have a lot of reading to do because the owner's manual is like 680 or 690 pages, and then on top of that, that's just basically for the base unit. That's not manuals for options. So yeah, there is a lot of reading to do. Now I've figured out pretty much most of it just with playing around with it. I'm familiar with using Roda and Schwartz equipment and communications test sets, but this one just has so many more features. One of the main reasons I wanted to get this was it's going to allow me to do so many more things than I was able to do before. For starters, I can work on lots of different types of radios now. Now, depending on what options you get with this, you can work on a really broad array of different types of communications equipment. Now, in the future, there's, God, I'd have to look it up. It's somewhere between $12,000 to $15,000 worth of options I still want to buy for this. And that's even not going to be all the options. It's got the options in it that I need right now to use for what I want to use. But for in the future, there's about $12,000 to $15,000 of more options I want to buy, and I'm going to be buying. But this thing does everything. Analog, normal radios that everybody's familiar with. But one of the main reasons I wanted to get this was I can do digital radios. So IQ, time and frequency, phase modulation. It covers military radios. If you're into aircraft, you can do avionics with this. There's an avionics software package you can buy for this to do aviation style radios. Like an amateur radio, DMR, fusion, pretty much any of the digital modes you can think of, moto, turbo, all of that, this test set will do. Public service radios. Trunking systems, APCO, P25, all that kind of stuff. This test set does that. You pretty much name the modulation type, it will do it. And even if it doesn't do it, if someone comes out tomorrow with a new digital format, it's just a matter of just upload it to the instrument. You can create new modulation types in the computer software, the CMA run, and some of the additional programs that run with this on a computer. And then you can interface with this thing with the computer. I can load, which is going to be something I'm going to be doing in the future. I need to familiarize myself really well with the base unit itself before I even get into computer controls and a lot of the automated tests. But it's going to allow me to do automated tests. I'm going to make up some interface boxes The unit has basically kind of like an accessory jack on the back. Has a lot of pins on it, but has TTL outputs, there's all kinds of digital outputs, and it has relays built into it. So this unit can control the radio. So like if I'm working on an amateur radio or a CB or whatever the case may be, I can come up with an automatic test, like an automatic receive and an automatic transmit test. In the program I would have it run, it'll test anything I want to test. It's just a matter of what you tell it to do in that automated test. But the test set can automatically switch the radio from receive into transmit. So that's what the relays are handy for, the built-in relay switching. It can switch the PTT circuits on the radios. But yeah, just so much I can do with this thing. Another thing I really like about this, which is actually that little small screen. So if I flip the radio back into transmit, right now I'm running a sweep generator into the microphone input of the radio, which actually just happens to be a Cobra 2000. And this is just going to be a really, really simple, quick overview of this instrument. I'm going to have to do a lot of separate videos on this instrument alone just to cover, because like I say, it does so much stuff. But just for a quickie, just so you can see what it does. So if we put the radio back into transmit, for starters, we can go full window with this, and then enlarge. This is an audio spectrum analyzer, not an RF spectrum analyzer. This is an audio. That's one of the big things I liked about this unit was it has a true audio spectrum analyzer. So from the left side of the screen here to the right side of the screen is 21 kilohertz. And you can see it down here at the bottom from 0 to 21 kilohertz. And yes, you see that little mouse pointer moving on there. I never have to touch the instrument. The only time I have to physically touch that piece of equipment is to turn it on and off. Everything else I can do with a mouse and a keyboard. I have a wireless mouse and a wireless keyboard for that. So yeah, I never have to touch the instrument anymore even. It is a touch screen, by the way, but it's got a couple buttons there and a knob there. That's pretty much it. Everything you would do through the touch screen, or like I say, with a mouse. But yeah, it has the audio spectrum analyzer, which is really nice. Of course, like in this case right here, we're doing, if I just stop it for a second, I enable a maximum marker. And that's another thing. All the spectrum analyzers in this, the audio and the RF, have full marker functions like a normal spectrum analyzer. Click play again, and you can see what it's going to do is it's actually mapping out as it comes across. It's going to fill in, just like it would on a normal RF spectrum analyzer when you do a max hold, and it's just going to slowly nibble away at that and fill that in. But this is a sweep of the audio spectrum now. So instead of RF, we're actually looking, because what this instrument does is we're transmitting with that radio down there. That goes into the RF connector. The communications test set demodulates the transmitted signal, and then it can analyze all of the normal audio measurements I do on radio receivers. We can now do that on the transmit side of the radios. So we transmit into the communications test set, it demodulates it, and we can run a full audio analysis on transmit audio now. So that's really, really nice. But like on here, you can see there's a little bump here. So on the left-hand side, you can see that there's really no audio response, really low frequencies. And it comes up to a little peak, it flattens out, and then starts to drop off. Well, if we want to take a close look at that, well, we can just zoom in on that section, and there it is. Really easy. And as you can see, and actually I can pause it. So just turn the radio off so it's not stuck here transmitting forever. But we can go into a lot more in-depth, detailed look at these waveforms. Take measurements on these, because you can switch the marker functions on. So if you want to take any measurements on the audio spectrum. But yeah, just really, really handy. We'll put that back to play. Let's see. Back here, turn it off the max hold, go back to the smaller window, and then the double window. If I go back into transmit, of course, it's measuring frequency, frequency error, power, modulation depth, THD, THD dB, THD plus noise. We can go into the trim view, which is kind of a handy, matter of fact, let me just disconnect, or actually I'll just turn the mic gain down on the radio. And let's enlarge this. So that's full window, but these are nice bars. Now this will be more for receive measurements, but yeah, like SINAD measurements, you have all the little bars down here. You can set where at what point these little bars turn green and red. So like for SINAD, we would be setting that for 12 dB SINAD, so it would stay red anytime it's below 12 dB SINAD, and when it gets above 12 dB SINAD, it turns green. So great for when you're aligning radios or checking sensitivity. Go into the power measurement. We're still transmitting, so you can see it's 36.11 dBm, or if we want to measure in some other form, so that's dBm, we can switch to watts. Oh, wait a minute, I need to go, actually have dB set in here in the RF settings, so we'll switch it to watts. Now we can measure in watts, or you can do whatever you want, milliwatts, dB watts, volts, millivolts, dB millivolts, and dB microvolts. So yeah, basically pick your poison, whatever you want to do. Let me take it back, take the radio back out of transmit. Don't want to transmit, you know, continuously with this poor radio down here. Switch that back to dBm. FFT, the spectrum analyzer. So here's the RF spectrum analyzer. Now, this actually has almost, I guess you could consider it, 3 spectrum analyzers. It has the audio spectrum analyzer, it has the FFT spectrum analyzer that you use in this transmit test, and then it has a normal spectrum analyzer with tracking generator, and I'll get into that in a minute. But yeah, this one, what it does is it sets whatever you have your center frequency that you're using as the center point, and then you can see along the scale down here at the bottom, that's in kilohertz, so you know, what is that, 10, 20, 30, 40, 50, 60, 70, 80 kilohertz in either direction. So, you know, if I turn the mic gain up, you can see there's our upper and lower sideband peaks, and you can also see all of the distortion products here, the second, third, fourth, fifth harmonics, you know, the audio harmonics going across there. Turn the mic, there you go, modulation back off. Adjacent channel power measurements, really quick and easy, right there, bam, there it is. There's 36.15 dBm on the center channel, you know, minus about 29 dBm in the lower adjacent channel, minus 29 in the upper adjacent channel, and then 2 channels away we're at minus 42 and about minus 42. And again, if we, now here's, you know, where it gets interesting. Watch what happens when you apply modulation. Look what happens to the power in the adjacent sideband or the adjacent channels as that audio frequency sweeps across. Because remember, we have a sweep signal running through for modulation right now, but you can see how high the adjacent channel power gets at certain modulation frequencies. So yeah, just so much stuff I can do with this thing. There's transmit test, which is what we were doing there. You can go into receive testing, so, you know, doing receiver measurements. Again, you know, same thing, we can do audio, all the audio testing, so THD percentage, THD dB, THD plus noise, SINAD, signal to noise ratio. You can take all of those measurements. Again, just like with transmit, let me turn off that peak marker, has the audio frequency spectrum analyzer for the receiver, the audio frequency oscilloscope. You can do multi-tones with this thing. And actually, when it comes to tones, like for receiver testing, it handles everything. Select call, DTMF, CTCSS, you know, all your PL tones, DCS. Even if there's something that's not in it, again, like I said, you can create your own audio files, modulation types and whatnot to apply to signals in this thing with, you know, the external software, and just load it into the instrument. Of course, you can go into the DX test, because you can see they have the little antenna transmitting for TX, the little radio receiving the signal for the receive, but you can do it like most communications test sets. They have an DX, and different manufacturers call it different things, but the DX is a receive and transmit, so it just automatically switches back and forth. If we go take a look at the spectrum analyzer, so this is a full-fledged spectrum analyzer, full marker, measurement functions and whatnot. Now, unlike most communications test sets, one of the things this has that most communication test set spectrum analyzers don't have is a tracking generator. It just uses because it has a very high precision signal generator in it, it just uses that signal generator for the tracking generator, which kind of makes sense. I mean, that's what a tracking generator is. It's just a swept signal generator. So yeah, but that's really nice. So honestly, I can almost take that instrument off the bench. I really don't need another spectrum analyzer here. For now, that one's staying though. And this instrument covers up to 3 gigahertz. So it has, where that spectrum analyzer below it only covers up to 1.5 gigahertz, this instrument will do everything you ever, basically any type of radio communications, 3 gigahertz and below. It covers it all. Everything I rattled off before, to include there are programs for this for doing GPS simulations. So if you work with GPS type receivers, you can simulate GPS satellites with this for testing GPS receivers. Does constellation patterns and IQ data patterns for when you're doing digital modes. Check car remotes, remote control airplane controllers. I mean, it's just, man, just does so much stuff. It has the expert view, which if you go into the expert window, this is where you can change a lot of things, where in the TX, RX, and DX positions, they're just basically fixed test parameter, tests setups already. Where when you go into the expert mode, that's where you can do a lot more fancy stuff. One of the other things, especially for me, is I also work on stereos. So this also does FM stereo, and it does RDS. So if you in a modern car, let's say, when you turn your radio on, you're listening to a broadcast off the air, but it's scrolling the artist's name and the name of the song you're listening to across the screen. And a lot of times, like the radio station ID, and then if there's a traffic emergency or stuff, they can scroll traffic information across the screen of your radio. You can do that with this test set. It does the digital RDS or RDBS data. This also does high definition stereo, so it has on the back side it has a couple extra jacks on it for SP diff, which actually right there you can see there's a little SP diff logo. That is the Sony Philips high definition stereo system. So it fully supports high definition stereos, testing stuff like that. Yeah, just again, just so much stuff this thing does. Yeah, audio, this is if you're mainly just doing audio work, so this is the audio analyzer. And then if you go down to like the sequencer tool, I don't have anything loaded in because I haven't done anything, literally anything with the computer program yet. Like I say, I want to get very familiar with the base unit before I start generating test sequences to stick into this thing. But yeah, at some point, I'll be able to... Yeah, it's starting the sequencer. I've clicked it in because I don't have yet. I can't connect the sequencer right now. Yeah, that's because I don't have the LAN cable attached to the radio, or not the radio, from the instrument over to the computer. I don't have the LAN cable attached to it right now. So, but yeah, it loaded up some samples here like APCO. So that, which is a C4FM type. There's a couple samples that they have in here for test simulations and whatnot. There's 3 APCOs. There's a DMR custom demo. Yeah, there's a Skippy speed test. But yeah, it just like I say, I got a lot of reading to do, Lucy. So, and again, the bench is another thing vastly changed. That's why I had to completely dismantle the bench. You're going to notice some wall space, a lot more room here than there was before. A lot of pieces of test equipment just went away. I'm not going to say I'm going with a minimalist workbench, but honestly, I had a lot of duplication. the BK 1040 and 2040 CB signal generator and service, excuse me, and Service Master, they honestly never got used on this bench anymore, really. Don't need them, away they went. The CMU 200 communications test set, again, it's redundant. This thing does so much more than that instrument ever could have hoped to do. Like I say, I don't really need that spectrum analyzer, but I've got that one hooked up for separate testing, so that one's going to stay. The other plan was I didn't want to go filling in every nook and cranny on this bench because there's some other things that are going to be changing here on the bench. In addition to buying lots more software for that instrument, an oscilloscope. I want to get a new, and I'm shopping right now. Probably going to be Roda and Schwartz. I'm kind of stuck on Roda and Schwartz. Love their instruments, and that's probably what I'm going to end up getting is a Roda and Schwartz oscilloscope. But I really haven't decided yet if what I want. At a bare minimum, I want to get a 1 gigahertz. But depending on price and options, how many channels I get. I may get a 1.5 or even a 2 gigahertz oscilloscope. 1 gigahertz I kind of want bare minimum. That will allow me to basically view almost all of the normal frequency spectrum, the amateur radios. Granted, 23 centimeters is going to fall out of that, but 33 centimeters, you're in the 900 megahertz range. So a 1 gigahertz scope would be okay. 1.5 would be better, but yeah, it's probably what I'm looking at. I'm going to get it, like I say, bare minimum 1 gigahertz. So that's one instrument I'm going to get. Also going to be getting another multimeter. Haven't decided there actually if it's going to be a Roda and Schwartz or I might go with a Keithley. They've got some really nice large 6.5 digit multimeters with just huge displays on them. Really nice looking meters. I might get one of those. But the thing is, like that oscilloscope, it's really big. One of those 1 to 2 gigahertz scopes is going to be like 1.5 to almost 2 times the size physically of that one there. So that's why I'm kind of leaving space open. I also changed the location of the communications test set. This shelf, I actually was going to build all new shelves. And I just repurposed the ones that I already had on the bench, and it actually worked out rather well. That shelving unit used to be over here. This shelving unit used to be over here. This used to have the CMU 200 sitting on top, and then other equipment down below, and then this shelving unit actually just got flipped around like this. It used to be over here with the signal generator and the oscilloscope, but then the spectrum analyzer was on the bottom, flipped over here. So I just rotated that shelf around. And yeah, for now, this is going to work, for like the next year, 6 months to a year, whenever I start, replacing some of this other equipment with much better equipment. But yeah, so there's just a brief overview of some of the stuff that does. Like I say, basically, if it's radio communications, 3 gigahertz and below, that thing does it. Everything. Doesn't matter what the modulation type is. So yeah, it's just going to greatly increase the type of stuff I can work on and the precision. That's the other thing. Really high-end instrument there. Some of the other things I'm going to be able to do with that instrument. As it sits right now, I can do screen captures on it, just load them onto a thumb drive or shoot it straight to a printer. But when I have that attached to the computer, when I start making up those automated test sequences, so like this radio down here, let's say, somebody sends a radio in, I can do a before repair analysis on it, and then after I'm done and alignment and everything's done and the radio's ready to be sent back to a customer, I can do another performance test. Do the automated test where it's hands-free. You just hook it up, click start, and just sit back and let the communications test set run the entire test sequence. But the thing is, I can then print out a full test result, basically a calibration sheet. So just like you get for your instruments, for the calibration that comes with that instrument, I will basically be able to do the same thing now for radios. Just like when you send your instrument into a calibration laboratory to get it calibrated on its normal scheduled maintenance, I'll be able to do basically the same thing for radio. So when I do those tests, I'll be able to print out those results and send them to the customer, either a paper or email it to them in a file. And they'll have a full test analysis of their radio. And like I say, I'll be able to do that before and after. There'll be probably a small additional fee for that because that thing wasn't cheap and it's gotta pay for itself. And that's going to be extra work too. But yeah, for people that want to go that extra mile, if they want that, I might offer that, and that's going to be in the future. I got to figure out exactly how I'm going to do that and whatnot. But yeah, so like I say, some of the other instruments came off the bench. Basically put on here everything that I have to have. Yeah, I guess a few extra things, but comms test set, of course. Spectrum analyzer, yeah, I didn't have to have that back on the bench, but that's going to be nice because currently, like, I have that and the oscilloscope hooked up through, just like before. Bird directional coupler up there comes out, goes to the splitter combiner, and then I can still shoot RF signals. So basically, I have two RF test setups here. I can transmit straight into that communications test set and do a full analysis. I can also just use the original setup I had before, transmit into the bird directional coupler. The sampled port off of that goes to the splitter combiner, and then that splits the signal out to the spectrum analyzer and the oscilloscope. Like I say, that kind of gives me two completely separate RF test systems that I can use. Of course, multimeters, had to have those, capacitor analyzer. The watt meter is also attached in that system because actually it goes to the bird directional coupler. The output of the drive side of that thing goes to the watt meter and then to the 1,000-watt dummy load on the floor. And speaking of wattage, that's another thing that's really nice about this instrument. Most communications test sets usually have a maximum power of between 50 and 100 watts. This one can handle up to 150 watts. Now it can handle 100 watts continuously. You can start transmitting into that and just walk away and leave it transmitting for a day if you want. At 100 watts, not going to hurt it. It can take 100 watts continuously, and it can take 150 watts for 1 minute continuously, and then you have to do a 1 minute cool down, 1 minute transmit, 1 minute cool down. But yeah, so it can handle up to 150 watts. That's going to be great for working on amateur radios. 100-watt amateur radio rigs, they're 100 watts, so that can easily handle them. So yeah, my PA stereo analyzer for when I'm working on hi-fi stereo equipment, still have to have that. And yes, we still have the old signal tracer, because no repair bench, in my opinion, is a repair bench unless it has a signal tracer, because there's nothing better for working on circuits a lot of times than a signal tracer. Of course, some frequency counter. Of course, another requirement, at least for my standards, is a GPS time and frequency standard. So of course that goes to the distribution amplifier. So all of these instruments are running off of a very high precision 10 megahertz reference signal. Now that instrument has the optional ovenized crystal oscillator, so it has a precision time base to start with, but that's even more precision because that is locked to a GPS signal. So that's why the second light there is GPS locked. So it takes its ovenized oscillator frequency, compares that to the signal being received from the GPS satellites, and you come up with an extremely precise 10 megahertz reference signal. Then that goes to the distribution amplifier and then goes to the reference input on all these other instruments. So they're all using the same time base, so that's really nice. So basically you can hook up a radio and transmit into every single one of these instruments. The oscilloscope, the communications test set, that spectrum analyzer, any of the frequency counters, and they will all measure exactly the same frequency because they're all using the same high precision frequency standard. So that's what's happening on the bench here. I still got a lot of cleaning up to do. This took me a while to get all this squared away and how I was going to do it. Oh, and another thing I got here was nice brand new shiny bench mat. So yeah, new equipment on the bench and whatnot, and it got rearranged a little bit. So another brand new ESD mat on the bench. Last one I kept because it's still actually in really good condition, but it's only like, I think 2 years old or something like that, maybe a year and a half, something. But yeah, I got a nice shiny brand new one to stick on the bench here. So Yep, so in the future, look for some videos with me describing in detail some of the tests, because I really want to cover some of the tests that that thing can do, so in the future I don't have to describe exactly how I'm doing and what I'm doing with that instrument. You can watch those videos on what it's doing, how it's doing it, and whatnot, and you'll just know for the future. When you look at the screen of that thing, you'll know what I'm talking about. Like I say, I need to get familiar with it. I'm already pretty good with just doing the analog stuff, but yeah, now I need to do the computer interface, and then with digital communication and a lot of this remote control and making up some connections, like I say, so I can use it to control radios. Need to work all that out and get some adapter boxes built for doing that for the remote switching. So there you go, Roden Schwartz CMA 180 radio test set on the bench and ready to rock and roll.